Hello students, I am Sanjay Manghnani, Assistant Professor Mechanical Engineering Department of Arya College of Engineering and IT. In this lecture, we are going to discuss the topic bearing classification. This topic comes in the 5th unit of the machine design subject of 6th semester Mechanical Engineering branch. I think all of you know about the bearing. Bearing is basically a mechanical element that permits the relative motion between two parts with the minimum friction. It also prevents the motion in the direction of the applied load. The bearing also takes up the forces that act on the shaft or the axle and transmit them to the frame or the foundation. So these are some examples of the bearings. This is the plumber block bearing. This is the ball bearing, and this is a roller bearing. Now classification of the bearings. Generally bearings are classified in two ways. First is on the basis of the direction of the load to be supported, and second is on the basis of the nature of contact. On the basis of the load, we can classify the bearing as radial bearing and thrust bearing. As shown in figure, in radial bearing, the load is perpendicular to the axis of the shaft. This is the shaft, which is a moving element, and this is the bearing. So this force P is perpendicular to the axis of the shaft. So it is called a radial bearing. If the load is perpendicular to the axis of the shaft, then the bearing is called radial bearing. In thrust bearing, the load P is acting along the axis of the shaft. So second classification is based on the nature of contact. On the basis of nature of contact, bearing can be classified as sliding contact bearing and rolling contact bearings. In sliding contact bearing, basically sliding takes place between the two parts of the bearing. In rolling contact bearing, basically steel balls or rollers are introduced between the surfaces that are in relative motion. In this lecture, we will cover sliding contact bearing in detail. So sliding contact bearing. As already discussed, in sliding contact bearing, the primary motion between the bearing and the moving element is sliding one. Sliding contact bearing can further classified on the basis of the nature of the sliding. So first is the slipper or guide bearing. In this sliding contact bearing, the sliding takes place in a straight line. As shown in figure, this is the moving element and this is the fixed element. In this moving element can move to right or left in a straight line. So this is the example of the slipper or guide bearing. This is another example of the lathe guideways. Second is the sliding contact bearing with the motion of rotation. In this, sliding motion takes place along the circumference of a circle or an arc of a circle. It can be either radial bearing or thrust bearing. If it is a radial bearing, it means that load is perpendicular to the axis of the shaft, as we discussed earlier, and also the sliding is along the circumference of a circle. This is the shaft and this is the bearing, and sliding takes place along the circumference of the circle. So these bearings are called journal bearing. So what is journal bearing? Journal bearing is basically the sliding contact bearings in which the load is perpendicular to the axis of the shaft and the sliding action is along the circumference of a circle. In thrust bearing, the load is along the axis of the shaft and sliding takes place along the circumference of this shaft. Now journal bearing or sleeve bearings. Journal bearing can be classified on the basis of angle of contact between the moving element and fixed element. If the angle of contact is 360 degree, then the journal bearing is called full journal bearing. It can take loads in any radial direction. This is the example of full journal bearing in which the angle of contact is 360 degree. These bearings can take the loads in any radial direction. Second is the partial journal bearing in which the angle of contact is 120 degree. This is the example of partial contact bearing. This bearing can take the loads in only one radial direction. The third is the fitted journal bearing. Basically, in full journal bearing and partial journal bearing, the diameter of the journal is the moving element and bearing is the fixed element. So, in full journal bearing and partial journal bearing, the diameter of the journal and the bearing is different. So, there is some clearance between the diameter of the journal and diameter of the bearing. But in fitted journal bearing, the size of the journal and the size of the bearing is same. So there is no clearance. So it is called a fitted journal bearing. Second method to classify the journal bearing is on the basis of the method of lubrication. Basically, in journal bearing, to reduce the friction between the two surfaces, the journal and the bearing is separated by a film of lubricating oil. So, according to this method, we can classify the journal bearing as dry friction bearings, self-lubricated bearings, thin film bearings and thick film bearings. In dry friction bearing, no lubricant is used between the two surfaces. In self-lubricated bearings, solid lubricants such as graphite, molybdenum disulfide and tungsten disulfide are used as a part of the bearing material. In the thin film bearing or boundary lubricated bearings, there is very thin layer of the lubricating oil, so the working surfaces contact each other at least a part of time. In thick film bearing, there is a thick film of the lubricating oil between the two working surfaces. So, the working surfaces in thick film bearings are completely separated from each other. Thick film bearings can further classified as hydrodynamic lubricated bearings and hydrostatic lubricated bearings. So what is hydrodynamic lubricated bearings? In a hydrodynamic lubricated bearing, the load supporting fluid film is created by the shape and the relative motion of the sliding surfaces. The principle of the hydrodynamic lubricated bearing is based on the fact that the viscous fluid resists being pushed around. As shown in figure, the load is acting downwards, and when the journal is at rest, it will touch the bottom of the bearing. As the journal starts rotating, it rolls up to right, and as the speed increases, the journal forces the fluid into wedge-shaped region. This is a wedge-shaped region. As more and more fluid is forced, a pressure is generated within the system. This is the pressure generated by the oil, lubricating oil. This bearing is also known as the self-acting bearing because the pressure to support the load is generated due to its own. This pressure basically supports the external load. So this is the principle of hydrodynamic bearing. Now second, thick film lubricated bearings are hydrostatic bearings. In hydrostatic bearing, the pressure is developed by an external source like a pump. As shown in figure, the journal is pushed up by a pressurized lubricant supplied by an external source like pump. This type of bearing is also known as externally pressurized bearing. So this is all about the classification of bearing. In next lecture, we will discuss some design concept of the journal bearing. Thank you.